In this video, I will make suggestions about how you can make your own contributions to the problem of predicting cancer immunotherapy results. So the first possible way to improve prediction is to make averaging with more classifiers. Now there are more than 50 predictors available, and here I only use 2 of them. You can also try more sophisticated sampling techniques like stacking. More importantly, you can help by finding more data. More data is always more important than better algorithm. Most papers use fewer than 300 patients. That's 0.3% of the 100,000 patients treated with immune checkpoint inhibitors in 2018. So it's a very small fraction, and the rest of the data is lost, it's buried elsewhere in medical records, or it's not even collected. It's good to observe that the cost of data acquisition is not the problem. Bulk RNA sequencing is very cheap, it costs $175 per sample. It's less than 0.4% of the total cost of the immunotherapy. This total cost is minimum $70,000, so it's completely another order of magnitude. So there is this absurdity that RNA sequencing costs dropped, but clinical data is still hard to get. And I think that this data scarcity is artificial, and I guess that the bottleneck is in the bureaucracy. Big hospitals and big pharmas have a lot of data, but they also have a lot of inertia, and they adopt technologies very slowly. So in my opinion, it's all about bureaucracy. And a good way to check bureaucracies is activism, and I think that new data activists can accelerate data liberation. They are even more important than data scientists, because data scientists are limited by data scarcity. So I think that activists can help bureaucracies realize that cancer lives matter. And now there is a growing movement of activism about healthcare. Finally, I think you can contribute by providing incentives and money to this ecosystem. In particular, I think that alternative ways to do research should be encouraged. These alternative ways can grab low-hanging fruits that remain under the radar of traditional research organizations. So I think that it's important to support a diverse research ecosystem. For example, here in my work, I think that ensembling methods were underappreciated in the literature, even if they are routinely used elsewhere for other problems, because here they were not a good strategy for building intellectual property. Because the average predictor is not self-contained, it depends on base predictors that are often proprietary, patented, or otherwise unavailable for commercial use. That's not an attractive direction for the industry or for venture capitalists who are looking for intellectual property. Likewise, this direction is not attractive for academics because they often use their university labs as launch pads for spin-offs. So in conclusion, I think that private initiative and private charity will remain a critical element of the landscape. You can support my work by making a donation at melwi.com/donation. You can also ask for collaboration at melwi.com/collaboration. You can also share those videos with your friends and colleagues.